A hearty welcome to one and all. As you remember, this is the 7th session. We have already completed 7 sessions out of another 4 are there. Four more sessions are there. And for the information of all the participants, as promised, all the first 4 sessions, that is Introduction to Structural Engineering as a Responsible Career from Surya Prakash, then how to begin and complete a good structural design of a project by engineer Basuraj, computation of loads and loads in buildings of different typologies by engineer C.J. Raghunath, then foundation types of independent combined draft. All these 4 are already made available to all the participants on the slide share. The 3, including today's, will be made available probably early next week. So another 4 more to go. And then as far as today's talk is concerned, we have Ravindranath PV with us, and topic is going to be on steel structures and pre-engineered buildings, design, detailing, and execution. So this, as the title says, this will be in 2 parts. Dealt by Ravindranath, today's speaker. Part 1 will be steel structures, wherein this part of the presentation begins with the introduction to the topic, encompassing the design aspects, codes of practices in use, and practical considerations in fabrication and erection of steel structures. And part 2 will be essentially on the pre-engineered buildings, introduction, need of PEBs, MBMA specifications, components, parts of PEB, design, detailing, fabrication and transportation, erection at site, precautions in erections, overall commissioning, advantages and disadvantages, and some case studies, photographs and videos. So I'm sure we're all going to have a very enriching experience. This is as far as today's talk is concerned. A brief introduction of the speaker today. Ravindranath graduated from civil engineering, from NIE Mysore, 1984, and did his post-graduation from structural engineering from PSG College, Coimbatore in 1987. He commenced his professional career at Design Consultants as a design engineer for about 3 years, then moved on to gain field exposure for about 10 years. During this period, he worked with Saravana Constructions, Favorite Developers, JMC Projects, Holzman, Videocon Engineers, in various capacities from project manager to general manager, involved in construction of buildings and complexes of national and international importance. By 2000, he founded his own consultancy firm, Ravindranath and Associates, offering architectural, structural, MEP, and project management and construction management services with specialization in industrial projects. Passionate to work with NGOs and self-help groups to provide socio-economic solutions and bring a change in the livelihood of the needy. His passion also expands in providing consultancy to eco-friendly and sustainable buildings. And this is about today's speaker. And as we have been having a special panelist, a member who probably will conclude the session with his special remarks and probably bridge the gap between the topic of the day and what the industry looks for, and will also probably share his experience. He is none other than our own member, engineer T. Raghavendran from Coimbatore. Engineer Raghavendran is a postgraduate with about 37 years of experience as consulting engineer and has successfully executed several time-bound projects. He is a senior professional engineer registered under Engineering Council of India. Specialized in establishing oncology infrastructure and hospitals, beautiful field, and designed and executed long-span industrial structures at very early stages, and has introduced innovative techniques for quicker completion within reasonable cost. He is currently involved in several sustainable and retrofitting projects. He was also appointed as a steering committee member for a World Bank project, Urban Land Market Assessment Study for Coimbatore, LPA, during 2003. He is a member of several professional bodies, including Institution of Engineers, ACC, Indian Concrete Institute, and several other professional bodies. He was the founder secretary of ACC Coimbatore Center and was its chairman during 2000 and 2002. I welcome you, Raghavendra, as a special panelist for this session. And now with this brief introduction of the speaker and a special panelist, Raghavendra, I hand over the floor to today's speaker, Engineer Ravindranath Levy. I welcome you all participants to the wonderful session. I'm sure we are going to have one more, yet another enriching experience. Thank you very much. And floor is yours, Ravindranath.
Thank you.
I request all the participants to kindly mute their audio and preferably videos also, so that the clarity would be better. Thank you very much.
Thank you, Dr. Ajit Sabnis. For the kind words and the introduction. Gurubhyo Namaha. Salutations to all my gurus. My first guru in the profession, Dr. Ram Prakash, as Professor Krishnamurthy, who is coming from our own institute from the earlier batch, 1952, what he mentioned right now, and all other. Sir, salutations to all of you, and let me start today's presentation on steel structures and pre-engineered buildings. So initially, when the whole thing was formulated for SES, Structural Engineering Series, to mentor and to enhance the knowledge mainly for the students and the freshers. So we thought of various topics on this, and then we had discussions with Dr. Sabnis and other members. Then Dr. Sabnis, after going through many of the suggestions, have come out with about 11 topics which are appropriate, pertinent to the freshers as well as the engineering students also. On this, yes, we have already covered, as mentioned by Dr. Sabnis, we have already covered about 6 topics. I would like to go through that once again, because everything is, all these topics serve as a preamble for engineering students, because it so happens in most of our engineering studies, we study at least about 40 plus, subjects in our course. And most of the freshers and engineering students will be in a dilemma as which is the one which we have to really get into, or how do we remember all this, which is more important and all. Well, as a civil engineer, all subjects are important, but in our day-to-day life, there are a few things as a structural engineer which keeps more importance for that. First, we saw, as mentioned by Dr. Sabnis, we heard about Dr. Surya Prakash from Hyderabad talking about introduction, overview, and challenges and opportunities, which is very, very important, because that guides, creates a passion for every engineer as what he should be, looking forward into the profession. Then our own colleague Baswaraj spoke about how to begin and end framing and deliverables. He also spoke about the analysis, design, drawing. These are very important. This is absolutely necessary in any project we take up, because where to start from and how do we start from and what are the things we have to deliver. So all these things he spoke very passionately. I know he's very passionate about his profession, and we're lucky to have, in us, because to discuss and to deliberate or talk about that any time of the day. Then we had our own colleague, Mr. Raghunath from Coimbatore, speaking about loads to be considered and computation of the loads for a structure. It was a very nice talk. I think he elaborated on various topics because, see, in any structure, the loads are very important, and what loads to be taken and how we have to compute them, especially the wind loads and the gravity loads, both put together. All these things he dealt with very elaborately, and that also makes my job a little easier because I don't have to touch upon those topics in my presentation. Then we had Satish Raipure from Nagpur speaking about various foundations, which are very, very important. The foundation of a structure which goes underground not only depends on what you do, it also depends on various soil properties, soil structure interactions. All those things were dealt by him, very nicely dealt, and we heard them. Then we had Dr. Yadunandan from Mysore speaking about design of RCC elements, very close to the steel structures. One of the other thing is the RCC elements. He spoke elaborately on various design aspects like working stress method, ultimate stress method, and the limit state method, and how it has come, what is the basis of consideration, all those things elaborately he talked about it. Next, last week we had Mr. Vadalkar from Bombay talking about software applications. What are the tools we can use and what is available for the design and drawing? Then what should be the input and what should be the output, and how do we have to interpret the outputs? All those things were very nicely told. So all these topics are interrelated one to another because most of the things, whether it's an RCC, steel, see, all these preamble, whatever we had so far, are going to be there. The next one, what I'm going to probably make an effort to speak about is, as mentioned by Dr. Sabnis, is in two parts. One is the steel structures, and the other one is and the pre-engineered, prefabricated buildings. So let me begin with the steel structures. On the screen, you will see a very beautiful building here. This is, we all know that it is from the Beijing Olympics, steel structure which is built for the Olympics, especially the arena area, and it resembles a bird's nest. And the way he has created that bird's nest in steel is really mesmerizing one. Probably we take a lesson from all this and then we go forward into that. Next is, what I'm going to cover in my topic is the introduction, a little introduction about the steel structures, then materials, specifications, basis of structural design. I'm not going to deal with the design completely, basically because of shortage of time. Some of the basic structural design considerations will be dealt with. Then mainly I want to concentrate on the connections. So connections are very, very important in steel structures, whether it's going to be bolted, riveted, or welded connections. Then let me speak, touch upon topics on design of members, whether it is tension member, compression, beams, plate girders, of course, gantry girders. Maybe because of the lack of time, I may not be able to complete all, but some of them we'd like to touch upon all these things. So this is where it is. In the once again, you will see one more photograph of a nice steel building with which has been used in the Beijing Olympics last time, and this is once again a nice building which has been done with the steel. Now coming to the next one, we have. See, we have seen different principal building materials so far. And what are the principal building materials we come across in our day-to-day life? One is the masonry, whether it is a brick masonry or stone masonry, which has started from very long time. If you remember the old structures, the hinge structures from the England, they're all with the masonry aspects of that. And then there was probably I don't go in the order of the same, but different materials which I speak about is about reinforced cement concrete, and the latest ones are the pre-stressed concretes. Then there are structural steel members or structural steel, which is come into play. Then there are wood. Wood is also a primary member, which we use in many of the constructions. Then other members like fiber reinforced plastic, FRP, or aluminum. And nowadays, what has gained more importance and more in vogue are the composites. So we see a lot of composites being used in many of the construction fields. This. The historical usage of steel. Steel is being used since quite a long time. Since 3000 BC, it has been in use. If you want to give a little bit history, we see what a photograph here. This is the Ashokan pillar from the Gupta period. You know, it's about 1500-year old, and still it is very nicely maintained and very nicely as it is available there. If you remember, the steel being used mostly, started being used in the construction, and the first one being, to be used is a cast iron bridge, which was built over River Severn in England in the year 1779. So first to be introduced in that series was the cast iron, and it was used till 1840. Then there was, with the change in carbon contents, wrought iron was introduced with that. So with the wrought iron, also there was a little problem with that. And then, some more research got into using the steel. Steel, which was introduced in 1740 and commercially patented in 1855. Now, more usage of steel is in the RCC as a reinforcement and also as a buildings, more so in the steel buildings, bridges, and various other usages which we are going to see here. And during the Industrial Revolution, it became more prominent because of the starting of the construction of the various industrial buildings and other buildings also. Steel was started gaining importance with that. So let me get a little bit more into the steel industry as how iron and steel is made into that. We have very large integrated steel plants. Probably the one which started first was the integrated steel plant from Tata's in Jamshedpur, and then there were so many other steel plants which started, and now we have at least about 5 to 6 integrated steel plants manufacturing various steel sections and then the ingots. And then we have a mini steel plants where the small ingots are taken from the integrated steel plants and then start re-rolling it, or mini steel plants. So that the major steel plants we have, as I mentioned earlier, are about 6. We have in Bokaro, we have in Vizag, and we have in Jamshedpur. So all these things contribute. In fact, the consumption of steel in our country as an Indian consumption is about 33 kg per person per year, whereas in other developed countries like in China, it's about developed countries about 300 to 500, and 220 is in China. So that means our consumption of steel is much lower compared to other developed countries. The production in our country is almost about 108.5 million metric tons. And then the steel is produced in various designations to start with. We have Fe310, Fe410WA, Fe540B. Let me get into that. What is this Fe? Fe stands for ferrous, or the ferrous material or the steel. The next one number, what you see is 310, is the characteristic ultimate strength in MPa expressed. And then whatever you get later on, W denotes the weldability or the weldable grade. And then the A, B, C, what you see there are the grades. Grade A refers to IS 2062 for general applications. Grade B refers to brittle fracture for steels used in particular locations like bridges, or grade C refers to low temperature and impact resistant steel. So this is about the steel industry. Then we have a greater advantage in the steel, as we all know. We all have studied and we all know that this is the perfect example to follow the Hooke's law in the elastic limits, as you can see in the stress strain curve, which you can see here, the Hooke's law, where the material properties, that is the E, modulus of elasticity, can be obtained with that. So this follows very well, and that is one of the greatest advantage of it. Then the advantage comes into fire resistance, hardness, the ductility, and the structural steel products. We have various structural steel products, which will be available for use. As you can see here, we have hot rolled sections and plates of different sizes. Hot rolled sections, we get angles, channels, I sections, T sections, the plates, the strips, flats. So there are all these things, round bars, tubes, hot rolled, all those things, what you have mentioned or what you can see on screen here. And then there are cold rolled sections, which you use for various applications like channels, jets, angles, hat sections, sigma sections, which we use, which I'll come to later in my presentation, where particularly which are the places where we use that. And then we have hollow steel sections like RHS, SHS are rectangular hollow sections and square hollow sections, and then the round sections. Then there are different sections which can be made, like welded hybrid sections. Either you make a built-up section or castellated beams. Castellated beams, which, I mean, for the beginners to say that, say from a ISMB 300, we can always castellate to form ISMB 450, like what you see here, where you will get the openings in between, it's cut into a particular shape and then re-welded together, so that we can get the properties of ISMB 450 with the ISMB 300. So like that, the economy can be achieved. These are called the castellated beams. So that's how the advantages of steel members come in. Then the other advantages, as I mentioned, compared to the most commonly used material, the concrete, strength to weight ratio is 3.5 times efficient than concrete. This has got a high ductility and uniformity in sections compared to concrete or other materials, and these are environment friendly, material, what we see here, because all over the world we recycle more than 400 million tons. That is the 50% of the steel produced all over India. So this is quite environmental friendly. The very versatile material, formed to different shapes and ruled to variety of shapes and sizes. So as a designer or as a user, we get a variety of sections and the choices to do our works. And then prefabrication, that's one of the best thing. What we can do is we can make it prefabricate it at some other place offsite and then bring it to the on-site and then construct. So it gives you a better quality control, least site work, and you can have a proper planning and of the whole project, where you can achieve your project completion within a stipulated time. So we don't have to depend on various other factors in this. Then one of the other thing is the permanence of this structure. Well-maintained buildings last longer. The only thing is the maintenance is required, which I come to that later. And then easily modifiable. Addition, alterations are easy compared to concrete. Wherever you wanted to increase one floor or you wanted to have some projections or cantilevers, all those things are much easier to do with the steel members. Then the fracture toughness is much better, can be bent, hammered, sheared, hold, all these activities it will undergo that. And then the elasticity, as I mentioned earlier, behaves close to the design assumptions of whatever we do with that, so that for a designer it will be much better and easier to work it. Now, what are the disadvantages? Disadvantages for these steel structures is, one is the maintenance, because every steel structure needs to be maintained. Corrosion is the biggest thing. And then also maintenance in terms of if it is a bolted connection, so we'll have to check the strength of the bolt over a period of time. All those maintenance requires, one of the disadvantages for this. Then the fireproofing cost, though material as such is, it can withstand the fire, but over a period of time or over when large heating does it, then the material gets melted in a high temperature. So the strength gets reduced in the higher temperature. Then one of the worst thing in this, as a designers or as engineers, we have to be very careful about the buckling factor. Susceptibility to buckling is very, very important. Then, of course, in the fatigue, though, of course, fatigue can be overcome with proper detailing and all, but still it is one of the disadvantages comparatively in this steel structures. So next on the what are the basis of structural design? Though, of course, as I mentioned earlier, I'm not going in detail up to the structural design because that is taught many a times in the colleges or in our curriculum. But what are the basis we have to take in? That's what we'll have to, I will be concentrating on that. Then what are the type of structure we IS code IS 800 2007 mentions about limit state method being used, but there are some cases or some of the places we may have to go in for working stress, ultimate stress, depending on the situation or depending on the case studies to that. Then the structural analysis depends on whether you're going for a first order elastic analysis, second order elastic analysis, where you consider only the elastic behavior of the structure, and then the linear buckling is being taken, then inelastic buckling being considered, then first order plastic or second order plastic analysis being considered that. So all these things forms the basis of our structural design and how it need to be. Though, of course, most of them have been covered in our designs in our academics, but still one need to get into what kind of basis are you looking at all these things. So next on this, the IS codes which will be used for the design or for execution are IS 875 part 1 for gravity loads, part 2 for live loads being covered already, part 3, 4 and 5 that. Then IS 1893 part 1 for earthquake loads. IS 800 is like a Bible for all steel constructions. This is a general steel construction IS 800. In fact, I used to tell all the students and the freshers that, the IS are the guiding ones for your, whether you are a designer or whether you are a site man. You should have read the IS 800 or any of the IS books at least a dozen times in your profession there, because you need to go through that, you need to refer to it, you need to, I used to say whenever I used to go to the colleges for student mentoring that read these IS books like a story book after you complete your examination, so that one by one you will come to know what are the aspects. You can start, in Sanskrit they say, manana and chintana, like that. You should go on reading and then, you should find out why it is, what are the things. Question yourself into that and then you'll find the answers for that. Then similar way, IS 808 gives hot rolled sections and IS 802 gives on the overhead towers. IS 806 gives on steel tubes. Then there are so many handbooks which are there provided by the Indian standard institutions. So SP6, one of them, I just took it, because so many things which will be helpful for both the design as well as the construction. One has to refer to that and then try to implement what is there in that and take them as a guideline. SP6.1 gives you handbook for structural steel sections. What are the sections we use? What are the properties? How we are going to use it? So all this gambit of IS codes and handbooks are quite useful in our professional life. Now, what are the design philosophies we need to adopt here? This is basically, see, sometimes what happens, many of the freshers and students may not be interested for the design, but at least you should know a little bit of what is it that is being done as a designer. First of all, we started with the working stress method. Probably Dr. Yadunandan has very elaborately covered earlier in his talk, but I'm just going through that in a very superficial way because I don't want to speak, take so much of more time on these factors. So where working stress method, we used to use the yield point up to the elastic limit we used to consider, and then we used to adopt loads, factor of safety for all these things. So that was the one thing which is governing the working stress method. Then the thought process went on a little bit for a little, changes and then alterations. Then we thought, why only consider up to the elastic limit? Why not we consider up to the ultimate sections and ultimate strength also? So ultimate load designs were coming into play. Then we started with ultimate load designs where load factors were considered. Load factors, probably many of the design books gives you all these aspects, what are the load factors for this and how it is being taken. Presently, in most of that, the thinking on the design philosophies came on two aspects. One is the ultimate limit state on safety and the limit state on serviceability. So the limit state on safety considers on the load factor, on the total load and how it is safe for that to take the load, whether it's in tension, compression, bending, and then all these factors. And then the serviceability limit state came into being where even though there is a considerable amount of deflection that comes in, as long as the building behaves well, we can still use it like that. So there are some limits on the complete serviceability which has been given in the IS code, and there are deflection limits for that. So based on that, we were able to do. So the partial safety factors for strength and serviceability for various loads and load combinations were considered for various loads and load combinations, so how much you have to take and what are the things of that. Then the most important thing here is, we started using the characteristic strength of the material. That's called yield strength, which specified that whatever we call it as a FC or FCK or FCT, it used to pass this strength passes 95% of the results will pass this. So that's how it is being considered in that limit state design. Then there was a structural stability, general stability, overturning and sway, which has to be considered in this limit state designs. Then there was a deflection, as I mentioned earlier, serviceability limits. So limits for various elements were given in the IS 800, gives us a guideline for us to design, and then we have to go for the design philosophy. So this. So now, going forward next to that, I would say the steel structures design is simple, but detailing is complex. So many of our colleagues are, whoever says that simple, it's very easy. You calculate the loads on any member and then you find out the Z for that section and then get the proper, section which has a Z, that's a section modulus. So your member is designed. But how do we going to connect from each and every member? Whereas in RCC, we have seen these are all formed together, the concrete is formed and then it forms an integrated joint. Whereas here we have to create the joint. The ingenuity of any steel structure depends on how well you have detailed not just the members, detailed the connections, and then how well you have understood. See, in many of our college days, and with no exception of mine, we have a little aversion to mostly steel structures because it's a little bit of complex, a little bit of difficult one. That's what I used to say. But actually, if you come to the field, having come to the field and seeing all these things, it's quite interesting. And once when you start developing a passion or interest to that, you will definitely like that. That's what my suggestion to all the young engineers, that you start visualizing all these joints, the sections and the joints together. One is individually and then holistically. Then you will come to know how good it is. You observe different steel structures, how well they have done the jointing together, and then how well you have, they have put the members in place, and what are the ways and means, so that, your interest will start getting more and more. When you become a little more interested, then the passion comes in. When you get a passion into that, then I'm sure definitely you will have a lot of liking for the steel structure. Well, that apart, coming to that, the bolted connections, where we use the bolts to connect one member to another member. So I'm not going much into the design, as I said, because the design of all these things takes a different, one more session itself. That's going to be a different session. But what I'm considering, or what I want to put across to all others is, what are these bolted connections? As I mentioned here, that you have different kind. One member comes in and the joins perpendicularly or at any angle, wherever, however the case may be. And those two are joined together with bolts. Now, what we do, we use different grades of bolts. We call it as a bolt grades with either 3.6, 4.6, 4.8, 5.6, 5.8, etc., etc. What are these 3.6, 4.6? It is the first letter, first digit, 3 or 4 or 4.8 or 4. In the 4.6, the 4 refers to the ultimate strength of that bolt, and then the next one gives you the ratio of ultimate strength to the yield stress, or yield stress to the yield stress is 60% of the ultimate strength. So that's how it is. For example, if you say 4.6 bolt refers to 400 newtons per millimeter square is the ultimate strength, and 60% of that is 240 as the yield strength. That's what you can see. So these are the things we can see. And then also depends on the size of bolts. You have different size of bolts ranging from M5 to M36. Please observe here the M, and then the number that comes in refers to the diameter of the bolt. Then we have different bolts. We have normal bolts like the ordinary ones, then the black bolts, then there are HSFG bolts. They are governed by IS 3757, IS 4000. Well, the black bolts are governed by the IS 1363. This is called a high strength friction grip bolts. So they are used for many of the automobiles industry, they use it, or even in our construction industry also we use HSFG bolts for a very important joints, or many times even some of the clients would require for the HSFG bolts to be used for that. Then what are the advantages of this bolted connection? The advantage of this bolted connection is it's very simple. And then unskilled labor and simple tools are necessary. You don't need a special tool or a specially skilled labor to have a bolted joint to be done with that. They are, when the fabrication is done, they are noiseless and very simple fabrication. No special equipment or process is required for the bolting of the bolted connections to be done. And then connection is through after tightening. Once when you tighten them to a particular or required level, check it, or you use a torque wrench to give whatever the strength you wanted it, and then once it is through, then the joint is done with that. You don't have to wait for that. So that's how. These are the advantages on the bolted connections. Next one on the, I may have to rush up a little bit. So we come across different joints, connections in this. We have concentric connections, like the way we see in many of the trusses, where the CG of the members join together or meet together at one point, and then we use gusset plates for the joints. So that's called the concentric connections. Then we have a moment connections. Moment connections are the way it's going to be a rigid frame, and the moment is being transferred in the joints. So we'll have to detail it in a different way for the moment connections. And then we have a beam column connections, which again is sometimes it will be a simple connection, or sometimes it will be a rigid connection. Suppose if you want to adopt, or if you want to transfer only the shear, then you go for a simple connection. Suppose if you want to transfer the moment also into that, you want to make it as a rigid frame, then you go for a rigid connection. So different ways of moment connections in that, we have bolted unstiffed end plate, or bolted stiffened end plates, or reduced beam sections we can adopt. So all these things come under shear connections, and then the moment connections with that. Then there is what is known as welding connections. So the second type is the welded connections, where the two members are joined together by heating as the fusion occurs at that place, and the base metal or the metal which is welding metal which is introduced will join the members together. So the advantage, we have different types of weldings here, the different type of joints. We have butt joints, we get lap joints, T joints, edge joints, and then so all this different kind of joints we come across in the welded connections. What are the advantages of these welded connections? It eliminates the holes in the members. What we saw in bolted connections, there was a hole which is done. That becomes a point of stress concentration, in very important places. Whereas with the welded connection, you avoid those holes there. Then the joint becomes airtight, watertight. So especially for containers or water retaining structures, so it will be very useful for that. And it is quite economical. Welding process nowadays is quite economical. There are a lot of ways, whereas the bolted connections, it will be a little more costlier. That joints are rigid and neat. The appearance looks very, very neat with that. The choice for designers to explore innovative sections. The one thing is you are not restricted only to use the standard sections. You can make your own sections of different sizes, different ways, different combinations together. So all these things gives you a choice for the designers. He'll be spoiled for the choices sometimes, so that what to use or how to use all this. Then practicable even for complicated shapes of joints. See, when there is a complicated joint, then the welded joint becomes, much easier compared to all other, like the bolted joints becomes difficult in that. Then alterations can be made easily with the welded joints, where you can weld another piece to a base member or wherever you wanted it. Either addition or deletion can be done. Then it can be made truly continuous structure is formed with that, with the quality of weld. If you are able to establish a good weld, and then it will be much more continuous. You can take as a continuous one. Then efficiency of joint is better, even 100% also sometimes you can take. Then stress concentration, as I mentioned earlier, is much lesser than. So what are the disadvantages? Well, disadvantages of welded connections requires highly skilled workmen. See, welding is a very skilled job. A person who doesn't do a proper welding, he will spoil the whole, both in terms of the strength as well as the look also. So it should be handled by a very well skilled persons who knows his job quite well. Inspection is difficult and expensive. Some of the times we have to do the inspection of the weld, either high penetration test or NDT. Sometimes you may have to go, depending on the importance of the structure. If the NDT has to be done, it will be a little more expensive. And difficult in field conditions, like places where you have to do the vertical welding. So when you have to do a vertical welding, then it becomes difficult. There are hardly a few welders who excel themselves in doing the vertical weldings always. Then the brittle fracture is more. So these are the advantages and disadvantages on the welded connections. Now, next one is the riveted connections. Though of course it's not been in vogue nowadays much, but it is more so outdated now, but it's more so equal or very similar to the bolted connections. Just mentioned, it will be a shank here, there'll be head and a tail. So I'm not going much detail into that, but what you can see, one of the iconic riveted connection building or structure is our Hoogly bridge across the river Hoogly in Calcutta is famous. And you see more of riveted connection in the old railway stations. All the platform structures will be 99% will be done with the riveted connections only. So this is about that. And then design of the tension members. So we come across various design, the tension, what are the tension members we come across? Say in bridges, the cable stay bridges or suspension bridges or whatever the bridges, most of them will be under tension with that. Then in the trusses, the roof purlins or the truss members, they'll be under tension. Then the roof truss, suspension bridges, these are the tension members which will have to be, considered for as a tension member. And then see, not going into that, I would like to give a little bit thought into these failure mechanisms of the tension members, which one should be aware of. See what happens in many of these things, when there is a excess load in that tension member, we come across gross section yielding failure. The failure pattern in the ultimate level will be a gross, the whole section gets yielded and it's a failure there. Or there is a neck section rupture, what is being mentioned here, the section there, because of that, gets ruptured into that. And then block shear failure. This is also one more failure mechanism which we should be aware of and keep in mind as designers for this. Then we come across the design of compression members. As I said, I'm not going much into the detail. So what is important here is to take there are short columns and long columns. See, the short columns depends on the effective length of the column, because in the short column, it's mainly the compression which will be predominantly acting on that. This is why it's called a compression member. So as per IS 800, we have different end, for different end conditions, we get the value of K. So with these values of K for different end conditions, we get the compressive load and then the ultimate compressive load, and then we design the section based on that. So there is a short column where the effective length plays very, very important factor in that. Now, coming to the next one, very short column subject to axial member compression fail by yielding or crushing, that is the compressive load, or very long columns fail by elastic buckling in the Euler mode. Intermediate columns generally fail by inelastic buckling. So we consider these long columns. Many times the long column, the Euler equation or Euler's buckling theory is of very significant here. It depends on the slenderness ratio of the member here. So that is the effective length divided by the radius of gyration. The more the slender it is, the less load it takes to that. So as you can see, the Euler's buckling theory gives this is the curve. Based on that, you work it out. You find out the the slender column buckling and then the ultimate buckling stress with that. So that's how we design all these aspects. Next, the one which is important in the failure mechanisms on this are the lateral buckling. So on these aspects, this again will be in the members subject to the bending. Now, what are the flexure members? So when the member is subject to bending, so it behaves or it is withstood by its axis, and then it starts undergoing the bending. So for that, we have different types of members. We have standard I sections, channel sections, angle sections, T sections, round sections, all this. And then you have different member or dimension, the properties of these members which need to be considered with that. So each, if you go through the IS or SP6-1, which gives about the dimensions and properties of the various members, then it will start giving the depth and the breadth of the flange, thickness of the flange, web thickness, all these things, including IX, then ZX, RX, IY, ZY, RY. These are all the aspects which we need to consider in which direction or in which axis you are considering the bending. So based on that, you have to design those members based on these section properties with that. Oh yeah, the time runs very fast. We don't know how it goes with that. Let me, thank you. So now classification of sections, as I'll have to rush through. Plastic sections are there where you have to consider different. See, for example, if you look at it, where the Young's modulus predominantly takes it's the elastic section, and then after that the plastic region comes into the play. So whether you are considering as a plastic section, the compact, semi-compact, or the slender sections into that. So this is the section classifications you will have to, where the stress factors will be governing, then how the stresses will be there, and then how it will govern the design or the behavior of the member. Now, factors affecting the bending strength, we have a laterally supported and laterally unsupported. So when there is a laterally supported, the members have to be laterally supported, otherwise the failure mechanism comes into play. Otherwise, laterally unsupported members, you have to treat it in a different way. So always better to go for the laterally supported members on this bending aspect. Then failure of flexure members, how failure happens, that in the ultimate level, as I mentioned, web buckling, web crippling, and the deflection. Excessive deflection, as I mentioned, are shown it here. This is what it happens in that. Then we come to the plate girder. So when the standard sections are insufficient to design a member, then what we do is we form the sections, what we call as a plate girder, where the flanges are web and the bottom flange, top flange, bottom flange, and the web plate will be made from the plates available, depending on whatever depth you wanted and whatever the width of the flange you want. So that's how we design the plate girders. The very important in all these plate girders is the stiffness. The transverse stiffness as the horizontal stiffness are very, very important because of the height variations. And then the splicing of the plate girders, so the plate sections. So you have to be very careful to know about all this. Vertical stiffness, horizontal stiffness, load bearing stiffness, end bearing stiffness are very important. And then the splices, you have to detail it. And if you are a construction man, you have to follow the splicing to the core, properly with that. So next, this is very, very important on the fabrication drawing and detailing. Probably we all know that, as I mentioned earlier, the very idea of your design ideas being transformed to reality is only through the drawings. Because what designer thinks, what he has in mind, that has to be transformed. So that's where the fabrication drawing and detailing should be very self-explanatory and very clear in that, as I mentioned, as I can show here, some of this, and should contain mainly the junction details are very important in that. And to take into account the erection methods too. When you are making a fabrication drawing and detailing, it is very important to have a discussion with the fabricator and the erector together as how it has to be, and then we have to detail it to that. The next is detailing of steel structure. As I said, this is one example on the truss. It's not just truss. We start with the general arrangement drawing. After the general arrangement drawing, then we have to see what are the different members, the sections, different sections. Then each section has to be detailed. Then each joint has to be detailed completely. Then structure, as I mentioned here. So nowadays we have lots of softwares which come in, and we can use them to get the detailing of the structures. That this is again a detailing of truss, as I mentioned earlier. Sorry. Then this is very important on the detailing of the welding joints. The weld symbols are the welding. See, we all have seen this. There will be an arrow. There will be line with this, the cross arrow, the leader line, the weld symbol, reference line, and the T, and the dash line. What are these refers to? The arrow refers to the place where it's needed. The welding is needed into that. See, and then we come across on this side, the far side symbol, you will have different symbols, the finish symbols. For example, if it is a square butt welding, different symbol here. The single V butt, different symbol here. So based on what you wanted, we get that. Then arrow side symbol, you get whether it is a number of spots, whether it is, how much of length, what pitch you wanted the welding. And then the root opening is mentioned here on this. So all these things, the tail will give you specific processes required. And all these things will give you, the welding, because this is how the welder will come to know how much of welding he has to do, what kind of welding he has to do, and then how he has to maintain the quality. See, this is how it is. This is again one of them. How it will be well joined will be detailed into that. Then very important is the bill of materials. You have to get the bill of materials properly, and then from after you finish your fabrication drawings, you'll get the bill of materials, and then the most important thing I would like to cover here is the building information modeling or the BIM modeling, which nowadays you can analyze or you can visualize the whole building together, as I said, because the complete information and modeling as per the exact sizes is it's what we get in the BIM. Helps to visualize the structure and then the joints completely. Interfacing of multiple disciplinary activities, like you can interface various activities that come in or various processes that come in, and then versatile softwares available here. The Tekla usually started with the steel, and then the Revit is there, ArchiCAD and XSteel. All these things will help us nowadays to go through the BIM modeling. Then the erection guidelines, very important in the erection guidelines, but because once when the material comes to the site, how you have to do the erection, to follow the instructions as per the design or whatever he has considered in the design. It is very, very important to follow safety guidelines very strictly, very, very important. Follow general and good engineering practices, and to specify the temporary supports needed during the erection as per design. There has to be a close monitor with the design engineer as well as the erection engineers are on the site with this. So these are the guidelines. As I've just given you, method statement has to be taken or prepared to erect the steel members. How we are going to do, what are the things. I'll just run through this because these are some of the things which we did. This similar ones we have used in many of this. So mainly, the bridges, what you see across in many of the places, where inaccessible places are difficult ones, so the steel becomes much easier, and then we can have this aesthetically looking very nice. It is. This is across River Ganga, RamJhoola Bridge, LakshmanJhoola and RamJhoola Bridge. What you see here, and in the night, it gives a spectacular sight to appreciate. As I was mentioning earlier, Hoogly Bridge. Really, it's mesmerizing things to see the whole bridge even today, and just stand below that whole bridge and keep seeing the joints, how beautifully it was done during those days. And this is one of the very famous Chenab Rail Bridge, which is being done now. It has become, it's almost completed now. That's what I was told. And this is one of the marvelous one. Really, we should be proud of having constructed. Afghans were involved in construction, and our own friend and our member J.B. Ravishankar is involved in pre-stressing and providing the support with all this. So these are the kind of things which gives us a lot of pride. This is a marvel of the nation, of the whole thing, and it's a sight to see after it's completed. So all these things will definitely give you that. So I just would like to give a small video on the how do I.
Just in India, ranging from 1 kilometers to 18 kilometers. This river is also known as a moving engine, and it River, the 4.94 kilometers long river.
Well, because of the time, this thing I would like to, because I was told that we have very less time to cover the another important topic. So let me switch over to the pre-engineered building, pre-engineered and prefabricated buildings is what the main of this. So unfortunately, I took quite a lot of time on the other one. So till the time the gets loaded, I would like to get into this part. As we mentioned earlier, we were talking. The main topic which has been one of them is this pre-engineered and prefabricated building. We have seen many of these things, with the advent of many aspects to this. So we have now, it has become much easier. I'll tell you my own example. What happened was when I was working for a construction company, one of the, the GM told me that we have to construct a factory building of about 6 lakh square feet. I said, fine. I thought it might take about 2 years for us to complete that. But he said later on that we had to complete it in about 6 to 8 months. I was surprised. I said, how can it be possible? Then when I discussed the same with our designer, who was none other than Umesh B. Rao at the time, and then he said, no, this is how it is. And it was in the late 90s that, that's when we started knowing about what is this pre-engineered building. Well, in fact, I would disagree with the name. Is a misnomer to say that pre-engineered, because all buildings are pre-engineered. It should have been pre-engineered and prefabricated buildings, because this whole building sorry, is prefabricated in the factory, and it's brought to the site, erected, and then completed. That what are these pre-engineered building? You can see here. I will be covering these are the contents of my talk here: introduction, component parts, design philosophy, detailing, fabrication, and design detailing, fabrication, transportation, and erection. So where it comes from? This, the whole concept, it started as our senior most member, Professor Dr. Krishnamurthy was mentioning, where he was a consultant to Metal Building Manufacturers Association in US. See, the lot of manufacturers actually came together to form Metal Building Manufacturers Association to give low-rise buildings for that, which came into being as a pre-engineered, prefabricated building. Now, the concept is to economize on the steel building design, optimum use of materials as required consideration, and then where you use hot rolled and cold rolled sections together, use of tapered sections, sorry, use of built up sections, and minimum sections to be about 4 mm and above. These are as per the MBMA specifications. The MBMA is the Metal Building Manufacturers Association, which started from the US, and that's how they started. Pre-engineered buildings are extremely quick and efficient. They have a simple design, are lightweight, easy to work, construct, and delivery. It's about 6 to 8 weeks, and it's about 15 to 20% cheaper than the conventional method. Cost and time of erections are minimized. PEB systems are extensively used in industries. The concepts were introduced in the 1990s, as I mentioned, and with the opening of economy, number of multinational companies have set up plants both to supply and use of these pre-engineered buildings here. Oops. I think what happened? They really will this time. Yeah, thank you. So you can see the beautiful pre-engineered building being done there. You can see the photograph. The market potential for pre-engineered building is about 12 million tons per annum, whereas the current production capacity is about 0.35 million tons. The industry is growing at a compound rate of 25 to 30% here, and can be fitted with different structural accessories, including mezzanine floors, canopies, fascias, interior partitions, etc. And these are PEBs are generally low-rise buildings. However, the maximum E height can be about 25 to 30 meters. These are ideal for offices, houses, showrooms, different. What are the advantages of this? The construction time is faster, and then installation is faster, lower cost, flexibility in expansion, larger clear spans, quality control. All these things are added for the most important one is the sustainable and environmental friendly. See here, what we come across as it is, steel structures are more sustainable. In that, the pre-engineered buildings are much better in that. So if you see the comparison, I'm just giving you on the same thing. If you look at it here, the whole thing, steel quantities on a conventional steel building was about 66 tons, and then it was about 61 tons here. And then thereby, even the foundation is also reduced in these aspects of that. So what actually happens in the pre-engineered building? For example, if you see here, the conventional building, we use a same cross section throughout, even for the primary member as well as the, the rafters as well as the columns here. Whereas in the pre-engineered building, it will be a tapered section based on the moment diagram, where what is the moment, and then what is the section required in that. Based on that, we use the sections here. Primary members are not uniform sections, tapered for compatibility of moments. Secondary members are lightweight, rolled Z and C sections. Erection cost and time are accurately known. Erection process is simpler, easy, and then delivery takes about 6 to 8 weeks. Whereas conventional building, it will be much larger, as I mentioned here. And delivery is at least about 20 to 26 weeks. That's what it is. What are the component parts we come across in this? Main is the stanchions, the columns. This is a typical industrial building where we have, side walls. Sometimes, in most of the cases here in India, we use walls up to 10 feet height, and then the sheet will be covered, and then the roof sheet will be there, the roof monitor will be there, and then these are the primary member, what we see here, and then the roof purlins, then roof ventilators. All these things forms the part of a component part of a pre-engineered building. The main frame basically includes the rigid steel frames of the building, the primary members. What are the PEB rigid frame comprises of tapered and straight columns, sometimes tapered, sometimes straight columns, and tapered rafters also, depending on optimally how much you need. The frame is erected by bolting at the end plates of connecting sections together. This is very important here. Purlins, girds, eave struts are also known as the secondary members, which are most of the cold form sections. There is no welding involved in their preparation at site. So it's going to be a bolted connection on all these places. So you are not going to touch, or you're not going to do any welding there. They are manufactured by the press bending of the HR steel coil, giving it the desired shape, whether it can be a Z shape or C shape, or the use purlin, whatever, use strut, whatever we use. These are the things we use. Then the main part of the sheeting here, the sheets also nowadays we get, steel, the sheets with a steel substrate, and then either it will be a galvalume or a zinc aluminum with a thickness ranging from 0.47 to 0.55 mm. The color coating is also available in various options. When the polyester paint, like a modified polyester or SPDF or a super polyester coating can be used. And then metal roofing and side profiles can be manufactured to any length depending on the transportation constraints. Or it can be site rolled. I'll come to that. The lap joints will be about 150 to 200 mm depending on the water ingress, and virtually eliminate the water ingress in the slope. At the initial project planning stage itself, roof slope is a key consideration for many of the architects and incorporating the roof systems into their designs. So slopes can be as shallow as 1:20. It's possible. And these profile sheets are usually categorized in two types depending upon the type of fixing arrangements. As I mentioned, the fixing arrangements can be either a through fastened or standing seam. Through fastened is where we lap one sheet to another, the fastening to the purlins, whereas in the standing seam, it's a total whatever length you wanted, you can take into that depending on, and these are all made at site only. This. And the other components that come in are the bracings, which are very, very important to transfer the lateral loads. The wind loads are transferred through the bracings, which has to be designed well. And there will be flashings and trims, what we see here, valley gutter, box gutter, ridge planes, corner flashings, gable flashings. All those things are the extras, accessories which come for the sheeting. And then the main one is the sag rods, connecting the two purlins here. They take up the secondary wind load being transferred here. And then there are roof ventilators and ridge ventilators and roof monitors to this. Then we can also have a mezzanine floor on these structures. So we generally take the main frames here, and then we use the steel deck sheets come in various thicknesses from 0.6 to 1.2 mm decking sheet thicknesses. Either it can be, either we can have in situ concrete on that. And very important here is to have the shear studs. The shear studs which transfer the load from main member through shear to the mezzanine floor. Or you can avoid these decking sheets, and you can go for the precast slabs also. So these kinds of mezzanine floors are possible here. You can see where all it is being used, pre-engineered buildings. And these are the design cross sections which we adopt here. Once you see here, basically this will be a portal frame, the main member, and then it will be column free structure here. It can be curved, it can be the lattice also, you can design it that, and then you can give the different joints here. The span is a consideration here. So usually maximum practical span is somewhere around 90 to 100 meters. You can go up to that, or otherwise you can go for the one side slope itself, which is maximum span of about 80 meters. 60 to 80 meters, depending on what the slope you give. And then it can be a multi-span structures, like single support at the center, or there'll be two supports in the one, or you can have a gutter frame at the center. So all these things are being done, or otherwise you can have a RCC column itself, and then you can have a framework here. So these are the different things are possible in these things. So what are the basis of design? If you see here, as I mentioned, for all the loads that come in, this will be the bending moment diagram which comes in here. So based on where the bending moment is maximum, we try to give the sections. Suppose if you see the conventional building will have a uniform section, whereas if you see the pre-engineered building, you have a tapered sections. So by doing this, we reduce on the material here, which is very, very important here. Comparison has already been covered. The design process, as I said, framing has to be done as per the structural conditions, depending on base, whether you take a hinge base or whether you want to take a fixed base, and then assume the sections for various parts. We'll have to check it up and apply the loading conditions as required for all other designs, and then run the analysis either on the STAT Pro or any other software, PEBs or MBMA softwares. Then take up the reactions and member forces, design each elements, and design joints, base plates are important here. Next is the framing components. I've covered that. So this is one of the examples which we had done. We're just taking it out. So probably given by one of the designers. So generally taken, the depth of the rafter is taken about span by 28, and minimum depth at the base is about 250 mm, and minimum web depth at the base is about 350 mm. And then width of the flange also is taken as D by 5, and then you work out. And then you have a standard flange width, which you can use from 130, 180, 200, 225. These are basically to have the support for the purlins that come in. Then the thickness of the web, depending on what you wanted it. So for the columns is different, for the rafters are different, and the flange thickness will be different with that. So with these principally assumed sections, then you can go and the analysis, the roof load, as I said, as per the IS, you take it, and then you take the imposed loads on all these things, wind loads also as per the IS, crane load, wherever it's coming. Then you have to work out the load combinations for the limit state designs. See, that's where you will have to frame it out for the analysis. After the framing, then you take the reactions. The reactions and the member forces are taken from this for the different load combinations. So based on that, you work out on the design various members. As I said, design the columns, design the beams, purlins, bracings, foundations, and joints and the connections. These are very, very important here. That. I think then comes the detailing. Detailing is very important. As I mentioned, say, as a designer, you'll have detailing. Nowadays, we have a PEB vendors. They will give you complete detailing of all this. As engineers, we have to cross-check all these aspects, whether what has been detailed by them is important or not. That. The next is how the PEB factory looks like. I would like to tell you a little bit. See, this is where the greater quality control on the welding of the beams. You have a beam here, and then welding is done automatically with the machines, and then you have sheet rolling completely done here. The sheets can be, and these are also for the HR profiles. So all these things will be covered there. I would always suggest that all engineers should visit at least one of these facilities to get a knowledge of how the PEB is manufactured. You can always go and visit the PEB manufacturer's facility. You'll get a greater idea. Then the erection is very important here. As I said, proper stacking as per the bill of materials. So once when the bill of materials is obtained from your fabrication drawings, and you have to start stacking properly, because they all come with very delicate sizes, and once if it is damaged, the whole thing will be a imprint on the whole thing. It will not be able to make good for the damage. So erection sequence are obtained from the designer or from the manufacturer, and then the proper cranes, tools, tackles, and safety equipments are used. Safety is very, very important, especially when people are working at heights. You should have all the safety gears. The PP kits, work there. Then there should be an erection manual from all manufacturers. I've seen main manufacturers like the Kirby or Everest or others giving a complete manual for erection, how it has to be done. The steel framing members are delivered at site and pre-cut sizes, which eliminates cutting and welding at site. And being lighter in weight, the small members can be very easily assembled, bolted, and raised with the help of cranes. And this system allows very fast construction, reduce wastage and labor, and buildings can be provided with roof decking and cladding too. So all those things, erection. This, as I mentioned, the erection process is highly technical and needs a skilled and trained manpower. Qualified and experienced work agency should be employed for erection. Very, very important that. So the next one. Let's say the flow chart for the PEB manufacturing process. I'll just keep it out. Very important is this bolt fixing. These are the first ones which come in. There should not be any tolerances with that, because they are coming with the particular bolts and then the sizes and then the distances. So column to column distances or bolt to bolt distance have to be properly ensured at site, because once if it is cast, you cannot undo that, because there will be a different process and it will be a very costly one to adopt for that. So this is how it comes. And then some of the things which we have done for the rice mill factory here, and then this is another factory building which we have done, not from a major manufacturer, but the manufacturer themselves. They created their own PEB facility for this whole this thing. This can be for a different winery. See, why I put a winery here is, we can use, we have used for a different temperature conditions here, ranging from minus 10 degrees to plus 4 degrees centigrade. So you have used lots of puff panels. All those things are being used. Can be used for various activities. That's one of the reasons why I was mentioning. And the erection process. And the very important thing here is, tying of the members, which is very, very important today. As the large factory span, you can go over the very large ones. So this is how it is. And then this is one of the showrooms and workshop which we did for almost in about 6 months' time. The whole thing was completed. So you'll be able to use them properly. That is another factory which we use. So thank you very much. Within a short period of time, I think I am able to stick on to the time. And that is, still, I had to rush through some of them. There's one video which I wanted to share, which gives you this. You have some time to share? It's about 5 minutes.
How long is the video?
It's about 6 minutes.
Yeah, I think we will just keep it for the end.
Yeah, fine. Okay, sorry.
Thank you, Ravindranath, for that excellent and lucid presentation. It was awesome. And there are quite a few questions for you. And by the time you take a look at the chat box and then the questions, I would request Raghavendra to give his remarks, his observation.
Yeah.
Raghavendra, are you there? You can
Yeah.
kindly unmute yourself and then start speaking.
Yeah, I have unmuted. Are you able to hear me?
Yes, we are able to hear you. Please go ahead.
Yeah. See, basically a steel structure with all its convenience and flexibility is strongest to the capacity of its weakest link. So that's what connections are more important. If a connection is weak, there is no point in the members or the whole structure or the framework being as strong and designed properly. Finally, it fails in the connections. So we should be very careful about the connections and detailing. Generally, in the regular steel structure, the designer and the fabricator meet only once or twice. So what happens is the drawings that communicate the fabrication system or how the structure has to behave has to be very elaborate and distinct in communicating the joint connections or the members or how the erection process.
Raghavendra, can you unmute your video, please? Sorry.
Start my video.
No. Can you? Yeah. Start. You can, so people can see you.
Oh, okay. Yeah. Okay.
Yeah. Sorry for the interruption. Yeah.
No problem. So basically, the design component and the erection process, the drawings that communicate are very critical in a steel building. This is what in a PEB, the design and the fabrication happens under the eye of the design engineer, and in a controlled atmosphere, like in a factory. Whereas in case of a general construction of a structure, any steel building, it happens in a site where the fabrication team is totally different from the totally new. He is not connected with the design engineer. And in most cases, the designs are being sent by drawings. So there is a lot of caution and precaution to be taken. And the other point where the steel structure has to be cautioned is the integration between the concrete foundation and the columns. If the centerline distances, the markings there is any shift in that, a steel structure will not allow more than 10 to 15 mm variation in the erection process. So what happens normally, a erection team, they will not be expressing their difficulties if they're able to manage. Manage in the sense they will pull the steel structure, a beam or a rafter, and then they'll try to erect it and close the system. But what happens is there are stresses induced before the actual loads are coming into the building. This we have witnessed in many places. But if you see a wholesome steel structure, it is like a web. It is like a matchbox. It is getting integrated in all directions. So what happens is these erection stresses sometimes are getting displaced or distributed through some other channel, that still the structure is being safe. But in a PEB, we have certain advantages like detailing and the manufacturing at site, and only the erection process happens in the site. So the guidelines for erection is more important here. And like I again mentioned, the interaction between the civil construction to the steel structure. There is another major limitation in the PEB structure. Like you are presented that the bending moment diagram decides the size of these members. You cannot add any superficial load, any additional loading system to the PEB structure after the structure is being manufactured. See, suppose you have an industrial building and in later stage they decide to have some compressor lines or some steam lines running under the roof structure. If it is not designed, it has to be cross-checked before implementing it at the site. So some of the restrictions in the steel, in the PEB structure has to be given a caution, and the drawings has to mention as to what this is designed for and what has to be brought back to the designer if there any change or requirement in the usage of the structure. And most of the PEBs we observe is of A shape, A structure, A roofing. PEBs, for example, when we requested for a north-light structure, most of the PEB manufacturers opted out of the contract. They didn't want to quote for it also. We said you can, we asked for a 56-meter span north-light lattice structure. We couldn't get any of the PEB manufacturer to come into and handle the project. So we had to go in for a HR sections and we had to go for a regular fabrication system. This is because the time consumed by the PEB manufacturer from the design stage to the completion stage to the dispatch to the site is quite huge. In the meantime, they feel they can dispatch about 15 other structures in a regular A construction. So these are some of the points we should request the PEB manufacturer to come out of the A roof type frames. And one more thing is that when you cross-check a PEB design with our IS codes, sometimes we see it may not satisfy in few critical requirements, but it will satisfy the MBMA requirements. So now legal considerations are being given more importance. Documentation is becoming very important, and the designer gets into indemnifying the structure for its usage. And all these things based on Indian legal conditions should be based on IS codes. So some of the gaps are there, but still I think the load factors and the safety factors are taking care of all these things. And we still get a letter of warranty from the PEB manufacturer. So these are some of my points. I wouldn't like to hold the discussions further. We can go ahead with the discussions and I can.
Yeah. Thank you, Raghavendra, for those insightful observations you have made. And now we will open the question and answer session. Speaker sir, for you, there are quite a few questions. And before actually taking the questions from the seniors, some of them who have asked, I would like to have, there are two questions which are from the students community. And Zulfikar, if you are here, can you go ahead with your question? Zulfikar? Okay, next we have question from Shubham. Is Shubham there? Okay, I think these students are not there.
Ajit, that's Ajit.
Yeah.
I just add on to what Raghavendra mentioned. In fact, in one of the projects which we did in a rice mill project, which I showcased in that, let's see, one of the, after the whole structure was done, before the sheeting, the erector of a machine came and loaded a crane pulley onto our structure, and it was bent. So we had to redo the whole thing completely and taking it out. As Raghavendra mentioned, it has to be predetermined loads and predetermined aspects. So you cannot have anything extra. Whatever it comes, it has to be an independent of the PEB completely. I was just supporting with whatever he was giving his comments. That. Thank you.
Yeah, Ravindra, there are quite a few questions. I would like to take two questions, one from Hemant Vadalkar.
Yeah.
Vadalkar, sir, you are there? Okay, he's not there. Then we have questions. Yeah. Vadalkar, sir, if you are there, then can you ask the question?
Yeah, okay. See, most of the times, as rightly pointed by Mr. Raghavendra sir also,
Yes.
when we check this PEB structure with our IS code requirements, many of the members, they don't satisfy the requirements. Like, for example, all these lightweight purlins and girds, maybe the bracings, they don't follow the tenderness ratio, right? I don't know. And the buckling criteria as per IS code. So then what is your comment on that?
So, I mean, see, they follow the MBMA specifications completely, and the MBMA specification came into being here mainly to control on that. And suppose, see, first itself they will ask whether you wanted it the IS code as per the IS code or as per the MBMA. Now, I would say that, see, even if you are following the MBMA, which has been accepted, and they also, I'm not too sure, in fact, Professor Dr. Krishnamurthy, who was a consultant to MBMA earlier, so probably if he is there, he can throw some light on that. But as I said, it is acceptable in all these places. See, our IS 800 is quite conservative if you look at it. So probably, accepting to the need of the hour, it might need to be changed. But at present, yes, as you rightly said, if you have to design it as per the IS 800, some of these things will not satisfy. I agree with that.
Yeah, I would like to add one point. If your client agrees to go by MBMA, then you are legally safe.
Yes, true.
Yeah.
True.
Yeah.
You're right.
So all you have to do is to get an acceptance letter from your client.
True. You have to safeguard your chair. As I say that. As a designer, I would say.
Sending a plan for approval,
Yes,
we get
yes.
indemnification that we will design, we will supervise, we will take care of the safety of the structure and performance of the structure. Most cases, the engineer doesn't even see the building.
Nice.
So we are even Tamil Nadu, we are contemplating about how to commit for this.
No, that's see, the attempt here is to introduce onto these pre-engineered buildings, basically. And there are some pros and cons, probably which will have to be taken at the proper fora, and then probably we have to, overcome all these things, as you rightly mentioned. See, there is one more question which I saw in the chat box. Probably he asked why the PEB structure is better than the normal building structure, which was answered already. And somebody asked which is the better, standard reference book for steel structure. There are lots of reference books, as you can see. You can go through that. Probably one of the ones which I come across is the very recent one by Subramaniam. Very exhaustive, very nice steel structures, and it is excellent one, which I've been referring to it many a time. Though, of course, apart from the Krishnamurthy sir's book also on this.
Yeah, now Madhav Kamath, can you please go ahead and then ask your question if you're there? Madhav?
Yeah, I'm there, yes.
Yeah,
Yes,
go
I'm
ahead.
there.
Good evening, sir.
Good evening. My first question is, in many of the PEBs,
Yes.
we see only single-side fillet welding.
Come again?
Many of the PEB structures, in the rafters and columns, many manufacturers do only single-side welding.
Uh-huh.
What is your opinion on that?
See, I think it's feasible. I mean, what I have seen that it is, one side welding, as long as you are able to take the structure intact and then pass through the whole test, that's okay. That's what it is.
Basically,
But see,
fusing, it amounts to fusing of the members, the flange and web. If it is properly fused and joined, it becomes a single member. Then it doesn't require a second side member.
but if you load it, if you were to load it, test it to failure, would it take the rated loading? Because it is recommended that some of the, when you have a fillet weld on both sides of the web, then the sum of the throat thicknesses should be equal to or greater than the thickness of the web plate. See, that is the
Pick up
requirement in
the loading, Mr. Madhav Kamath. I think
yes,
most
shear.
of the members, what has been, they are designed for a particular type of loading, and that has been sticking. We are not come across.
No, I am referring to the longitudinal shear between the web and the flange.
Okay, probably we'll have to revert back on that.
Okay. Madhav, I think both of you being senior members, I think you can get in touch with each other and then resolve this issue.
Yes, I can. I can send a mail.
Yeah.
I can send a mail.
Yeah. Then there are quite a few interesting questions from Mr. Anil Kumar. Mr. Anil Kumar, you're there?
Yes, sir, I'm there.
Are you there?
Yes, sir, I'm there.
Yeah. You be a little louder and then go ahead with your questions. I find your questions quite interesting. Please go ahead.
Yeah. So, my first question is going to be this regarding this. Actually, sir, you mentioned this SP6 in your presentation.
Yeah.
But, the SP6, most of the sections are not satisfying the slenderness criteria of the Indian code. And this is, we have not yet received any update on this SP6. And plastic properties which are mentioned in the IS code are only for specific sections. So total, this was not implemented in the SP6 for the all other sections which are shown in the SP6.
The SP6 is like a handbook. It's a guidebook, you know. So probably what has been given, if it is not updated, that need to be taken or these things. But you can refer many a times, you know, even if you want it for different sections, the manufacturers will give you all this, and then they are available in the other IS codes on this.
Yes, I agree. But what my take is actually mostly these sections are presently we are not using most of the sections in the SP6.
Yes.
If you see across. And one more thing is there will be equivalent section we can show in the SP6, which are useful for IS 800 present code. We can update SP6 based upon the present IS 800. That's what I'm saying.
Correct. No, see, we have to take whatever, wherever it's available. That.
Yes.
Okay.
I agree what you are saying. Presently, everything is on the manufacturing base. So Jindal is having some properties, Tata is having some property. That I agree. But at least one standardization to be required as per the present code. That's what I'm saying. That is for first question. And the second question is, most of the PEB vendors refer the MBMA code. That is a Bible for them, actually, I think.
Yes.
But presently in India, there is no initiation to consider their own standard, means PEB standard, based upon IS 800 and 2007. As you said, this is already conservative. I agree that one.
Correct.
But actually, there should be a forum which to be consider all these aspects and make a standardization, which to be approved by BAS also. That is what in my opinion.
You are right. As you mentioned it, there is no standard on that. I believe there is, the PEB manufacturers are requesting the IS also to come out with their specifications. That will be the work in progress, which we'll have to watch in the further one. For your first question, so as a designer, if we have to use a particular sections from Jindal, I would prefer to use it from a manufacturer, whatever he gives. For example, we get the parallel flange sections from Jindal, but it's not available anywhere in Indian codes. So we have to take it from the manufacturers, whatever they give, and then make use of it. Hope I have answered your questions. If you have anything more, you can write those.
Yes, sir.
Thank you.
And coming to the MBMA, sir.
I think give a chance to others to ask questions, Mr. Anil.
Okay. Thank you.
Yeah, students, if there are any questions, please go ahead. Please unmute yourself and then ask questions.
Hello, sir. This is Rohan Jirge from Thane.
Yeah, tell me, Ron.
Yeah, sir, you have told that we can ask the client for the stability, means he's ready for the MBMA for this certificate, right? But
Yes.
can we have our own code actually for the PEB structures? Can we expect a revised code for IS code for PEB structures in few years?
No, that's right. As of now, it has not come in. Even there's no committee also that's been formed. I'm not aware of it, but definitely when it comes with it, in the present situation, it is always better to ask the client and then take his concurrence to design for it.
Yeah. Okay. Yeah. Thank
Thank
you.
you.
Yeah, I think we have overshot the time. Participants, thank you so much. I would like to invite the closing remarks from Krishnamurthy sir, because he is one of the authors of the steel book. I think, sir, very briefly, in about 2 to 3 minutes, I would request you to conclude on behalf of ACC. I leave the floor open to you.
So we are honored to hear you.
Well, thank you. I'll try to be brief. Number one, MBMA sponsored my research on steel. Hello, can you hear me?
We can hear you, sir. Please go ahead.
Okay, now I'll be brief, but I'm open to contact by email later. I was in the US for 20 years, and during those 7 years of my research time, I spent on AISC and MBMA, who were very interested in one particular connection, the end plate connection. And to cut a long story short, after 7 years, I came up, of course, with the help of my students, I came up with a method which saved the industry 35% steel. Now, it's been a long time since then, but MEMA is a very dynamic, and Americans have the habit of very optimizing everything. And we must be very careful, and as has been mentioned, either we follow it strictly or don't go there. We cannot take a MBMA design structure and add anything or modify anything. But I come to the last point I would like to make. I am now focusing on safety and anything we can contribute to India. And I asked myself, don't we have enough talent in India to do something which I like, something like I did for USA? We have enough talent. I think we need the motivation, and once we do that, we have. In fact, I'm going to be in as an expert on a committee for safety, though. But I'm sure there are equivalent expert committees for the PEBs, and I suggest very strongly I'll be available for peripheral or out behind the scene comment. So anybody who is interested, I think we can do it. Who can have more talent than India? Third point, and the only thing in India is the designs are good, the materials are good, but the implementation is where the compromises are made. So I think with these few remarks, as I said, we probably need to discuss this in greater detail. Thank you for giving me an opportunity, because I'm grateful to MBMA, and I'm very personally pleased, but nationally, as a citizen of India, I would feel prouder to contribute to our own PEB designs, codes, and so on. Thank you, gentlemen.
I think we will take an initiative from you, sir. Thank you very much for your kind words, and be a guiding factor for all of us. Thank you, sir.
Congratulations.
Thank you, sir.
Thank you, Speaker Ravindranath. Thank you, Bhagwendran, and all the participants. I think this is the longest session in the last, among all the 7 sessions. And the question interaction was also very encouraging. So I think let us call it a day. Have a wonderful Sunday. And also I take this opportunity to wish you all a very happy new year, happy Ugadi to everyone. And let us again meet next Saturday. So I think we will call it a day. Thank you very much for being patient participants. So we will close the session here.
Thank you all.
Issue the same.
Thank you.
Yeah, thank you, Ajit.
Thank you.
Thank you, Raghavendra.
Thank you.
Thank you, sir.